This is Algebra 2. We're doing homework for modulus and argument. Again, the instructions, find the modulus, find the argument. Again, the modulus, a very fancy word for how long, let me switch to a different color, how long you are into the shadow dimension. And the argument is, again, what angle are you turning through the shadow dimension? All right, so 1 minus 1i, just visualizing where things are so I can check my work for later. 1 to the right, down 1. This point right here is 1 minus 1i. We usually call this 1 minus I. So how do we find the length? Well, it's using Pythagorean theorem. So I can say that that length is 1, that length is 1. Technically, this length is a minus 1, I guess, but length is always positive, so we're going to say that it's just 1. Using the Pythagorean theorem, we're going to say 1 squared plus 1 squared is equal to this length c, which is the hypotenuse, squared. So that's going to be 1 plus 1 is equal to c squared. 2 is equal to c squared. And to undo this power of 2, we undo it doing the inverse, which is the square root of both sides, meaning that c is equal to the square root of 2. That is one of the two steps. I found the modulus. Now I'm going to find the argument. And you can kind of see that I'm going in this clockwise direction. I know that my argument theta is going to be some negative angle. Normally when you go counterclockwise, we are going positive direction, counterclockwise is a negative direction, and it looks to be about 45 degrees. So I'm going to go ahead and say negative 45 degrees with a question mark and check to see if that's actually true. The way that we solve this is with a calculator. So let me get my calculator up and going. I'm using a scientific calculator. Let's move that to the left to make you a little bit smaller. So the way that we type this in is we type in ARCTAN of a fraction. So my fraction is going to be my imaginary unit. So my imaginary unit is -1. So I'll write out what I'm doing. I'm saying that this is the way that we do our argument. We say it's going to be arctangent of the imaginary divided by the real. And again, you're just looking at the coefficients here. So the theta here is going to be actually arctangent of our imaginary. Our imaginary in this case is a -1 because it's the number attached to the I. So I can say it's going to be -1 all divided by the real number. So the real number is just a positive 1. So I can come down here and say positive 1. If you just type this into the calculator, -1 and 1, you get, okay, it's negative 45 degrees, which is what we got. So I'm going to come back up here where I had the question mark. I'm just going to erase that. And indeed, that is the correct answer just by eyeballing it. So good job, me. Pat on the back. Pat, pat. All right, number 2. I'm going to do the same thing. And again, I like drawing these out just to make sure that I can check my work. For example, if I got like a positive 45 degrees, it was up here, I would know, oh, that's wrong. I need to go into the negative direction, into the clockwise direction. So having a visual inspection is a great way to check your work. So I'm going to go right 2. So I'm going to go right 1, 2. I'm going to go down a little bit more than 2. Again, the square root of 3 is about, I don't know, 1.7-ish, I think. So it's a little bit more than 2. I'm going to guess it's around 3.2-ish if I were just guessing. So it's going to be 1, 2, right about there-ish. I'm not sure, but it's in this area. So I'm going to call this 2 minus 2 square root of 3i. So notice that if I set up a triangle, usually we set up the triangle with this real axis. I should have a right triangle here. And again, I want to find what this length of c, the hypotenuse. And I know these lengths. I've gone right to 2 and I've gone down to square root of 3. Again, I'm talking about distance here, so I ignore the negative just for a second. And then I plug it in. So if you forget that this is supposed to be positive, you can leave it negative and it'll still work for this entire problem. In fact, I'll leave the negative and I'll show you. So let's go ahead and say leg squared plus other leg, which is -2 square root of 3. That other leg squared is going to be equal to the hypotenuse, which we're calling c squared. And let's solve. So this one is a little bit trickier and it does require some review. So 2 squared is the easy part. That's just going to be 4. This part is going to be a little bit tricky because whenever I have 2 things being multiplied, 2 things being multiplied, and it's to the raised to the power of 2, this 2 kind of distributes to both of these. And really what I have here is a -2 squared times a square root of 3 squared. That's kind of the distribution that I was talking about to each of these terms. There's 2 of those squares, and that's still equal to c squared. So there's a plus sign in between here. So this is going to be 4. Again, -2 times -2 is a positive 4. That's going to be multiplied by, undoing a square root and a square. Those 2 cancel each other out, and you're left with just a 3, and that's going to be equal to c squared. 4 times 3 turns into a 12. I still have to add the 4. 4 plus 12 is 16, so that's going to be equal to c squared. And then finally, I'm going to undo the square by square rooting. That's the inverse operation to get c is equal to 4. All right, that's the modulus. I've found that. Now I'm going to find the argument. Again, the way that we find the argument is we say it's equal to arctangent of your imaginary divided by your real. Well, my imaginary now is this -2 square root of 3. So I'm going to say -2 square root of 3 on the top. And my real number is this 2 right here. So I'm going to come down and say this is going to be 2. I just type that into my calculator over here on the left-hand side. I say this is going to be -2 square root of 3 on the top. The bottom is going to be 2. And you get -60. So theta is equal to negative 60. And I did make a mistake in this last one. I should have put degrees. If you don't have a symbol up here, you assume that it's radians. So we put that degree symbol to know that we're in degrees. There's two different units of rotation. So I have both of those answers, box it with pen, and I'm on to the third and final problem, which is a random number that I just made up. It's going to be a yucky number. So here we go. And just as a sanity check, I am going in the negative direction. I am going this direction, so I should have a negative number that works good for the argument. All right, time to go. Here we go. I have negative 1, 2, 3, and then negative 1, 2, 3, 4, 5. This number right here is negative 3 minus 5i. There's my line right here, and I'm going to do the Pythagorean theorem. So this is going to be negative 3 quantity squared plus negative 5 quantity squared, and that's going to be equal to my hypotenuse squared. Going quickly, 9 plus 25 is equal to c squared. 9 plus 25 is 34, is equal to c squared, and then I'm going to square root both sides to undo the square, and I get c is equal to root 34. If you do a factor tree for 34, you'll realize that none of them are perfect squares, I hope. And this is as far as I can go. So done and done. From here, and I find theta is equal to, again, arc tangent of my imaginary divided by my real. My imaginary in this case is a negative 5 for my numerator. So I say negative 5, and then I divide that by the real. The real is a negative 3. So I come down here and I have a negative 3. You could simplify this because you have a negative divided by a negative, but you don't need to. Just plug it into the calculator and call it good, right? So the bottom is going to be a negative 3. The numerator up here, aka the top of my fraction, come on, here we go, is going to be a negative 5. And I get this yucky number that I just randomly made up. Our theta is going to be equal to a positive 59.036 degrees. And this is not the correct answer. And I can see why, because normally, if I rotate from the positive real direction and I rotate 90 degrees into the clockwise direction, I'll end up here at 90 degrees. But you're noticing I have to rotate 90 plus another 90 plus some other amount and then get my answer. So this one feels off. This is why we make a visual inspection. So I haven't talked about this, and I'm sorry for throwing a hard one at you. What you should really have is 90 plus 90 plus this angle that we just found over here. We're going to talk about trigonometry and why this angle gave us the wrong answer. Essentially, we need to add 180 degrees due to the domain of this type of question. We'll talk about it in class. The correct answer here, we add 180 degrees. We get 239.036 degrees for our final modulus. And that does conclude our homework. Thank you for watching.